matter fullness of precaution, we're doing, okay, this is your quadrant of the house, this is my quadrant of the house, and be masked everywhere else. Because unfortunately, like, you have to walk down the hallway to use the bathroom in my house.
And so you're looking at like 2 weeks of caution. Yeah. Because for both of you, neither of you want to get this.
No, absolutely not.
Right.
Oh, but we're here to discuss science, which is far more exciting. Before we do, this is your reminder. Newest guidelines are... My dog just took my headphones off.
Those are not the newest guidelines. She can't hear me because her dog took her headphones off. There's no way those headphones are staying on. That dog is going to take them off every time.
So I have an emotional support dog quite by accident. I got her the day I quit a job, and she learned, because I picked her up every time I was upset, how to be an emotional support dog.
Right.
And she could tell I was upset talking about COVID and was simply trying to do her job. But what I was going to say is the latest guidelines are wear an N95 mask or a K95 mask with a surgical or cloth mask over it. So all of you out there, stay safe, double mask. We're going to get through this somehow eventually. But before we get through it, we're going to talk about science, because the science keeps going.
It's been a while since we checked in to make sure the universe was still expanding. Yeah, apparently that's still a thing. But in the last few years, powerful new telescopes and expansive surveys have given us much more knowledge about what's happening, especially at the earliest times. We'll talk about that in a second, but first let's have a break. And we're back. All right, Pamela. Now, we, of course, have talked about the expansion of the universe, the inevitable, ongoing expansion of the universe at the largest scales.
The heat death.
The eventual heat death. That the time when all matter in the universe was compressed incredibly close together. But every single part of this process is constantly being analyzed. And as it does, more questions pop up. New studies have to be made. New experiments are launched. New instruments go up. And so although we know roughly, the universe is expanding, there's like little pieces of this puzzle, like hundreds, thousands of little pieces of the puzzle, and scientists have been making really interesting incremental discoveries and advances across the board. And so there's some really interesting new advances that you wanted to talk about. Right.
So I want to assure everyone, at the biggest, broadest scales of understanding the universe, we have it. We've got this.
The universe is expanding.
The universe is expanding. We see the cosmic microwave background that tells us that the universe came from this thing that we have termed the Big Bang. We understand that cosmonucleosynthesis occurred. We get the correct ratios of the elements coming out of the Big Bang. Where we run into trouble is anything involving detailed understanding of structure or what has happened since that cosmic microwave background was released.
Mm-hmm. So let's talk about like what, again, in broad strokes, like we know we had the universe. The universe was a hot, dense state, cooled down to the point that in the beginning, it was opaque because it was so hot. It was like the interior of a star. Cooled down to the point, roughly the temperature of like a red giant star, red dwarf star, that light could finally escape out into the universe. What came next?
So at this point, our universe was a neutral gas for the most part. And it was more or less of constant density. But the slightest variations between that more and less constant density created places where dark matter and regular matter, the stuff we're made of, that our tables are made of, could gravitationally collapse into a density capable of forming stars and galaxies. Now, the timescales that happened on is our first point of confusion. Because really hot gas, you can't collapse it down. Really hot dark matter, not going to collapse down, simply because the energies of the individual particles.
If you enjoy Astronomy FM radio, please let us know with a small donation. We do rely on your support, and it's true. Every little bit counts.
AFM.
You are listening to a universe of possibilities. This is Astronomy FM.
Coming up next, an Astronomy.fm original program. It's time for York Universe, a co-production of the Observatory of York University, Toronto, and the Voice of Astronomy, AFM Radio.
Hello and welcome to York Universe, the astronomy and astrophysics program written and presented by students, faculty, alumni, and friends of York University. I'll be your host this evening. I'm Dr. Elena Hyde, the director of the Alan I. Carswell Observatory, and we are in fact broadcasting live from the Alan I. Carswell Observatory, located at York University in Toronto, Ontario, Canada. This is Science Night in Canada, where the lineup is all Canadian, starting with ourselves, York Universe, then on to Western World's Quirks and Quarks and Science for the People. As a reminder, York Universe broadcasts every Monday night at 9 p.m. local Toronto time. And if you want to catch any of our repeats, you can always check out the archive on the website for the observatory at observatory.info.yorku.ca. And in fact, that's exactly where you do need to go if you want to go and check out our online public viewing happening right now in concert with this production. The online public viewing is presented by the observatory team, also runs between 9 to 10 local Toronto time in the evening. If you go to that website, observatory.info.yorku.ca, follow the links to OPV, online public viewing. You can join in the chat and perhaps even see some real live images of maybe, the moon, and all kinds of other interesting objects from the 40-centimeter telescope on the atrium location. Our broadcast is powered by and in partnership with Astronomy.fm, the voice of astronomy. For any questions or comments you have of our past shows, or if you have suggestions for future topics, send us an email at observe@yorku.ca. Just as a reminder, we can also be reached on Twitter with our handle at York Observatory or at York Universe, and our Instagram at York U Observatory, as well as Facebook, Alan I. Carswell Obs. So lots of methods to reach out to us. All of our programs are free, but if you'd like to make a donation, you can also check out that website link from before, observatory.info.yorku.ca. We will be monitoring the chat room for questions and posting beautiful images. The weather is very promising tonight, so fingers crossed for our online observatory team. Now, to start out tonight, you might be thinking, well, how odd is it that we only have one host? Well, it's actually a trick. I have an amazing guest for you tonight with an interview that we'll get to. We have joining us today for the whole show, actually, Dr. Parandis Tajbaksh. Dr. Parandis, thank you so much for joining us.
Thank you. It's a pleasure to be here tonight.
We have all kinds of things we're going to talk about today throughout astronomy and history. In particular, Dr. Tajbaksh will be telling us about the really, really interesting 200th anniversary William Herschel astronomy event that ran last week at York University. And in fact, you might have heard the recording on York Universe if you were listening in. So we actually have a chance to talk about that and a couple other things from history. So we're not going to completely break with our format. We do have a couple fun this week in space and astronomy history to get ourselves started off with a blast, or a crash rather, on our York Universe radio show tonight. So we're going to go back in time, and that's a common theme here, going back and forth this week in space and astronomy history. So just as a reminder, today is the 7th of November, 2022. It is getting harder and harder to keep track of the dates this year. But if we go back a long, long ways, not 2022, but 1833, November 12th, there was an amazing astronomy event, the Great Meteor Storm of 1833. Now, around this time of year, the Leonid meteor showers, which are associated with the comet Tempel-Tuttle, are known to have pretty spectacular storms about every 33 years because the comet itself is periodic. So as the comet has an orbital period of 33 years, it basically restocks the meteoroids when it comes back around. And so you get these absolutely spectacular meteor showers every 33 years, and they tend to peak around the 18th of November. Sometimes they're spread around for a few days on either side of that, and you can get a zenith hourly rate of 15 meteors or more. The storms, however, can exceed 1,000 meteors per hour and sometimes 100,000 per hour. Depending on, of course, your variable. So your mileage will vary with these meteor showers. But in 1833, the timing of the storm was very, very significant because up until that point, meteor showers were thought to be just atmospheric phenomenon. But the storm spurred a lot of study into meteors, and they think that from the meteors that were watched in the 1833 storm, they think that this particular storm had maybe 100,000 to 240,000 per hour. Some of you might have seen in your historical browsings of astronomy, if other people do that sort of thing, maybe woodcuts and engravings from this event. There were a lot of beautiful pieces of art that came out of this. And there is a particularly funny one made by one Etienne Leopold Trouvelot. I hope I'm doing the pronunciation right. So this is found by actually Julie Tomei, who could not join us this evening. So hopefully I did her French artist's name justice. This particular artist, an astronomer and an amateur entomologist, was living near Boston. And he had meteors moving like billiard balls hitting the sides of the table in sort of J-shaped paths and wiggly paths. And as Julie would love to tell you, is I believe, and this is a quote from her, Monsieur, that is not how meteors work. So there's some very interesting artistic interpretations that happened. If you do get a chance to look up any of the original drawings from 1833, there are some pretty fun ones out there. And of course, the Leonids in history are very famous because they do have this 33-year period and because they can be so spectacular. Actually going all the way back to 902 AD, the Chinese astronomers have a description for the Leonids as one of the nights where the stars fell as rain. And the event was also picked up by observers in Egypt and Italy. So there are occasionally coinciding astronomical counts from cultures all around the world, even when they were not in contact, which is always really, really fun. So this particular 1833 meteor storm had an absolutely amazing number of events per hour, somewhere in the range of 100 to 240,000, and some interesting artistic interpretations as well. So I believe as our colleague, our astronomy.fm colleague from York University, Julie Tomei would be shaking her fist at the billiard balls of Trouvelot, but it is very artistic, I have to say. He is also incidentally credited with the introduction of the spongy moth to North America, which is another reason to possibly shake your fist at them. I do not believe that particular beast is very good for our North American trees. So we have a lot of examples of people witnessing this great meteor storm. It was actually recovered in North America recorded, I should say, by more than just people in Boston and other places. It was actually recorded as well by several indigenous communities, as well as African American slaves. The lone dog winter counts are the Lakota documentations of the passage of time, and used in conjunction with oral history, the winter or symbol is added to represent the year. So it was actually recorded, this event, in their count. And there was also an essay online from a descendant of African American slaves, a great grandmother of a young girl in the southern states in 1833, actually spoke of the events of that night for the rest of her life because they caused quite a panic in 1833. Some thinking it was Judgment Day, and there's you can look for Angel Fire, I believe, is the name of the article from this event. So it is very striking, and of course, if you're not used to this, if you hadn't been, over 33 years old, you wouldn't have had any idea this could happen. It could be quite unusual. So the Leonids are expected to peak on November 9th, by the way. So this year, we do not think that we will be getting hundreds of thousands. It will be more like hundreds per hour. So the zenith predicted hourly rate is something like 250 to 300 for this year. And the Leonids are again November 17th to 18th, both hemispheres, so southern and northern. And just in case you did miss the Orionids, we of course get more meteor showers coming up. So there's always something to look forward to when you're looking up in the sky. And of course, if you are out there on the peak dates, November 17th to 18th, you will have the best chance to actually see them above the horizon at midnight. So go ahead and prepare to stay up late. You will need to be out there around midnight, and around 1, 2, 3 a.m. it starts to get nice and high above the horizon. Again, lots and lots of reasons to stay up very, very late in astronomy. This is just one. So the Leonids are coming back, and of course, this day in history, the Great Meteor Storm. So this was a really fun one, and thanks to Julie for pointing this out to me, even though she couldn't be here today. So have you ever read anything about the Leonids with Herschel Parandis?
No, I have not. Caroline, his sister, she looked for comets and she discovered actually 8 comets, but with meteors, no. I have not read anything.
And it is worth mentioning that although this year was, of course, the anniversary for Herschel's death, Caroline Herschel was a notable astronomer in her own right, who did also have quite a few discoveries to her name. She might have actually had a lot more fun with the Leonids.
Exactly. She had her own telescope, and she was the first woman to be paid to be an astronomer by the king. So, without her, probably Herschel would never have achieved the things that he achieved during his lifetime. So she was really a big help and support for William as a younger sister. And later on, of course, John Herschel, who was William's son, was helped and supported by his aunt, Caroline, enormously, as he basically went up the steps of the ladder of becoming the greatest astronomer of Europe at the time. So yeah, she was an influential character.
Absolutely, and it is always fun to remember that these things do go around. So William and Caroline Herschel would not have seen these particular ones. 1833, they would have had a chance, but I don't know if it would have been visible for them, the Great Meteor Storm.
I don't know. I have no idea, but at least I haven't read about it.
Something for our listeners to puzzle about. Maybe it's in one of their writings and we just haven't seen it yet.
Maybe. Yeah.
So I'll go ahead and move us forward a bit. We have 1 or 2 extra things for this week in space and astronomy history. So just not to jostle us too much in our time travel, but going out of the great meteor storm of 1833, which is super fun, and actually we probably could spend a lot more time on this because, of course, the historical accounts have all kinds of interesting things. But one of the great things that came about was once people for This Week in Space and Astronomy History. So just not to jostle us too much in our time travel, but going out of the great meteor storm of 1833, which is super fun, and actually we probably could spend a lot more time on this because, of course, the historical accounts have all kinds of interesting things. But one of the great things that came about was once people realized that these meteors were not sort of atmospheric effects. They were actually coming from space, dust particles burning up. It sort of overturned a lot of old hypotheses. And I believe there is something about these post-1833. One of the things that came about was there is a 2,000-year-old doctrine, which has actually been developed by Aristotle, that held that meteors were fiery sparks of the remains of enormous gas bubbles that rose into the air before exploding high above the ground, which is a really cool hypothesis, but I have to say there's no evidence of this, right? So it's interesting that it managed to remain the dominant theory for almost 2,000 years until people realized what it really was. Anyhow, we're having too much fun with this. Let's go ahead and jump way forward to another fun November This Week in Space and Astronomy History. This one's a little bit closer to our current day, so we're currently on 7 November. We'll go to 2 November, but we'll jump all the way to 2012. So this is not so ancient history, but it's still pretty fun. And this week, a couple days ago, so 5 days ago, 5 days ago today, we had a really interesting space shuttle delivery to Kennedy Space Center. It was actually the Space Shuttle Atlantis on November 2nd, 2012, got delivered to the Kennedy Space Center to go on permanent display. So this was its sort of last resting place. And this was the fourth operational and the second to last space shuttle built. The Atlantis is named after RV Atlantis, which is a two-masted sailing ship that operated as the primary research vessel for the Woods Hole Oceanographic Institute from 1930 to 1966. So we can get back in history even farther if we want to. The 33rd and final mission was also the final mission of a space shuttle, the STS-135, on the 8th of July, 2011. So this was around a year before it was delivered to the Kennedy Space Center. So by the end of its final mission, Atlantis had orbited the Earth a total of 4,848 times, traveling 203 million kilometers. So it did get quite a workout over its life, and it had 156 individuals flying with that space shuttle over the course of its 33 missions. There's a few notable milestones for this space shuttle and a few milestones in its production. While it was undergoing, the contract was actually awarded to the Rockwell International Space Transportation. So we think of SpaceX now as kind of this new idea that a company could be helping out with the space shuttle sort of construction, but actually all the way back with Space Shuttle Atlantis, the contract was actually sent to somewhere else, Rockwell International, the systems division, and that was in 1979 originally. So assembly began in 1980. And it was completed in 84 and delivered in 85. The first launch was October 1985. So it was 1985 that it had its sort of, don't call it first light when it's a space shuttle, I guess its first launch. And then in 2011, it had its final mission on the 8th of July. A few famous missions of note for the Atlantis. It was actually used to deploy both the Magellan and the Galileo probes to Venus and Jupiter, respectively. So it's been actually used for all kinds of interesting things, not just people transport, but also spacecraft transport. It was the first space shuttle to dock with the space station Mir. And on subsequent missions, it actually came up and delivered and installed special docking module to Mir for space shuttle docking. And it had quite a few more visits to Mir after that. And it had a lot of assembly missions as well with the International Space Station, the ISS. So it's been very popular with space stations, and it did go both, quite a few times to Mir and quite a few times to the ISS. And it actually went right after the Columbia disaster as well, which was probably pretty tense. So it had the final Hubble Space Telescope servicing mission, which also very interesting. Hubble is back in the news with prominence with the JWST image comparisons at the moment. But Hubble has been one of our most successful space telescopes, I think, of all time. And of course, now that it's reached its final home at the Kennedy Space Center on permanent display, it's inside the visitors complex. It's in the building behind the full-scale shuttle stack of 2 solid rocket booster and an orange external tank. So it's displayed basically as only the astronauts have seen her in space. So rotated 43.21 degrees with payload doors open and the Canada arm extended. So that's basically like if it had just undocked from the International Space Station. So I don't know if they are currently open right now. It is 9 p.m. at night. But if you want to visit them, I think they do have regular visiting hours happening again at the Kennedy Space Center. So it's pretty fun. If you want to go in and see it, it's part of the general admission, I believe, and it's definitely worth viewing. I've actually never been out there, but I've heard it's very impressive. So this day, almost in 2012, and it's nice to know that the Space Shuttle Atlantis has a good home there. And Perendis, have you ever been down to the Kennedy Space Center?
Yes, once. Years
really?
ago.
You've been there. I'm jealous.
Yes. Yeah, it's a very nice place. It's very inspiring,
Did you see the Atlantis space shuttle?
I did. But of course, I was there with my family, and my son was pretty young, so I couldn't focus on anything. But at least I had a chance to take a quick look.
Well, it's quite the thing to see. I am well and truly officially jealous. Of course, I'm not sure how they were able to properly suspend it in there. They must have used some very strong braces, because the weight and height of this thing is very, very substantial. So assuming they stripped it down a bit, but when it came out of the Palmdale assembly, it was 68,000 kilograms or 151,000 pounds.
Oh my gosh!
So it's
unbelievable.
It's a pretty heavy item to try to display, but huge props to them for especially managing to not only display it but also to put out prominently the Canada arm.
That's right.
Excellent. There you have it, folks. Definitely recommended. Kennedy Space Center. All right. So moving up a little bit again, we'll go to our last This Week in Space and Astronomy History. We've gone through 2012, so actually we're going to take this time a really short jump and go to exactly today, November 7th in 2013. So this was an interesting time for space and astronomy. In November 7th, 2013, we actually had the launch of Soyuz, and some number soup, you'll have to excuse this, TMA-11M. So you might be asking, okay, well, what was TMA-11M? It was a flight to the International Space Station, which transported 3 members of the Expedition 38 crew to the ISS. And this was literally today in 2013. So that's always nice when we can find one that's exactly on the right day. So thanks again to Julie Tomei for finding this one for me. That we had on this launch cosmonaut Mikhail Turin, NASA astronaut Richard Astracchio, and JAXA astronaut Koichi Wakata. This was the first time since 2009 that we actually had 9 people on the ISS without space shuttle. So we had a rocket and spacecraft carrying up on this launch carried the Olympic symbols on the fairing of the ship because of the Sochi Winter Games, which were happening in 2013. So all kinds of interesting things get crossed over with astronomy history, including Olympic Games. During the mission, they actually passed the Olympic torch for the first time in open space. Russian cosmonaut Oleg Kotov and Sergei Ryansky, passed it in the Russian section of the International Space Station. So it sounds a little dangerous. And this again, we do know that fire in space is not a good idea. So we might ask, how would we pass the torch? They actually did it in a very, very simple manner. They simply left the torch unlit. So no flames, but the torch was passed nonetheless. So that is pretty kind of interesting that they were able to do that as part of their space mission at the ISS in 2013, and of course, having the Olympics running at the same time made for, I suppose, a fun way to involve everyone on Earth with what was going on up at the space station. So I don't know, 2013. I'm having trouble remembering where I was in Australia at that time. I think I was finishing my PhD, so I don't remember very much of that time at all, actually. Parandis, do you remember where you were in 2013?
No clue.
No clue. I was in Australia. I know that much. I was definitely in Australia.
I am pretty much sure I was in Toronto, and I had a course in astronomy. I was teaching a course in astronomy. That I'm pretty much sure. I was actually also doing a second graduate degree at York at the same time. So I guess it was super busy back then.
Yeah. Oh, yes, indeed. So all of us who are finishing degrees do not remember this actually happening, but it's great to read about it now. And
that's right.
I'm very glad that they did it. Excellent. Well, let me go ahead and put up a couple small reminders here. Just to confuse everyone and do this a little bit out of order, we've gotten through our This Week in Space and Astronomy history. But I do want to remind everyone that this week we do have our Teletube episode running on Wednesday, November 9th, and we will be playing the video recording from the Herschel concert from last week. So if you missed the slides, we do have a way for you to actually catch up on that, as well as hang out from your living room. Now, the other really, really big reminder that we have to do is this is York Universe, and there is a total lunar eclipse tomorrow. By tomorrow, I mean really, really late tonight so that it goes over into early tomorrow morning. So if you're in Ontario or the Northern Hemisphere, you will have noticed that the moon is in a completely full phase. And that you can see just by walking outside, the moon is up. The moon rose as the sun set. And it's a beautiful, bright, big, full moon traveling across the sky. And as it travels from east to west, it starts going in the direction of Earth's shadow. And the moon will pass into Earth's shadow early on the morning of basically tomorrow. So you'll have to stay up all night tonight or wake up at about 4:30 tomorrow morning. So around 3:02 a.m. on Tuesday morning, also known as very, very late tonight, the beautiful big full moon will be moving into Earth's shadow in the penumbra. So the penumbra, as the moon moves into it, is very, very subtle. Most people can barely see the darkening. It's a very small effect moving into the penumbra. So that's at 3:02 a.m. The moon will be 41.3 degrees above the horizon, but setting towards the west. As you go towards 4 a.m., the moon starts to go into the actual shadow, the dark part of the shadow we call the umbra. And of course, this full total lunar eclipse is going to get really, really good, and it will take a while. So as you're watching at 4 a.m., you get to 4:30, you still only have a partial eclipse. If you want to get to a total eclipse, you actually have to wait all the way until 5:16 a.m. basically. Or conversely, you can actually just get up at 4:30 instead of 3 and watch the last part of the partial eclipse as the moon goes into that total lunar eclipse. Now we expect this to be very, very bright and red, and it will also be very low on the horizon. At 5:16 a.m. in Toronto, the moon is only 18.3 degrees above the horizon. So watch out for tall buildings or trees. You want to have a clear view of the west. And any place in Toronto that you can find, or actually any place in Ontario, you can find a clear view of the sunset, you'll be able to get a good view of the moon set as well. So what I'm recommending everyone is 5 a.m., hop outside, see the very, very last part of that partial eclipse, and catch totality. The moon will be 18 degrees. It's going to look big and very, very red. Maximum eclipse is at almost 6 a.m. and it will only be 11 degrees above the horizon. The total eclipse will end just as the moon disappears completely beneath the absolute horizon at 6:41 a.m. Of course, the sun will be rising in the meantime. I do not think very many of us will be able to see it by 6:41 a.m. You'd have to have an amazing clear horizon out to the west to be able to see it that low. Or you'd have to be on a very high mountain maybe. So this is all happening tonight/tomorrow morning, and this is a absolutely huge event. Because it's so low on the horizon, we are not going to be able to show you images from the 40 centimeter telescope like our crew is trying to do right now, actually, over on OPV. So if you head on over to YouTube and look for the Alan I. Carswell Observatory, York Observatory YouTube channel, or go there from our website, they're looking at pictures of the moon through the 40 centimeter telescope. Right now, it's super high, it's full, it's bright, but by 6 a.m., it's going to be very low on the horizon. So we actually won't be able to point that low with our observatory telescope. If you head on over to YouTube and look for the Alan I. Carswell Observatory, York Observatory YouTube channel, or go there from our website, they're looking at pictures of the moon through the 40 centimeter telescope. Right now, it's super high, it's full, it's bright, but by 6 a.m., it's going to be very low on the horizon. So we actually won't be able to point that low with our observatory telescopes. We actually have to go to other locations. So we're going to work on getting a whole bunch of pictures for everyone and sharing them on social media as fast as we can. We won't be able to live stream it, of course, because we have observatory crew members going to all corners of Toronto trying to find that clear view to the west. I know that down by the lake, if you are around the Toronto area, that is a pretty good spot to view. Of course, if you can see the sunset, you'll be able to see the moon set, and that's what you need this morning, I suppose I should say, at about 5 to 6 a.m. Very, very exciting times, and very big reminder, because this news expires after tomorrow morning at about 6:45 a.m. when the moon finishes setting. So sunrise is going to be just after 7, so it should be very, very spectacular. I don't know. Do you have a clear view of the west, Perandis?
I have a good view of the west, but because this is so close to the horizon, I don't think I'm going to catch it, because there are lots of trees that are blocking my view on that side. So yeah, but I'm going to be up. I'm an early riser, so I'll try to see what I can see.
Yeah, have a look at 5 a.m. 5:30, like the earlier the better, and as it goes closer to 6, it'll get really, really low. But
Yeah,
if you can go for 5, you've got a really good chance of seeing that, and that actually goes for everyone in our time zone.
I think I can see at 5 o'clock, but I'll take pictures.
Yeah, absolutely. If you get any pictures, send them to the observatory. We want to see all the eclipse pictures. I am going to try to get to a location. I'm going to try to go down to the ferry terminal for that ferry to the island. So fingers crossed. And of course, weather allowing. So it's always possible we might get clouded out, but this is probably one of the biggest astronomy news events of the year. And I would like to point out that if you are anywhere in the Northern Hemisphere and have a chance of viewing this eclipse, it is highly recommended, because a lunar eclipse, actually, especially a total lunar eclipse in Toronto, we're not going to get another really good one for several years, actually. So it will be roughly 2025, 2026, I believe, before we get an actual proper full lunar eclipse, beautiful red moon in the Toronto area. Again, we do have some partial eclipses, but because it doesn't line up exactly, we won't actually get another really good total lunar eclipse until 2025. And actually, I think that Toronto will be part of that one. So it'll be a couple of years before we get another chance. Highly recommended. And of course, there is a solar eclipse coming in 2024. So 2024 and 2025 are going to be excellent eclipse years, but I recommend catching this one if you can. All right. So the moon... the moon will get us to our next fun topic, but let me go ahead and just remind everyone while I am remembering that you are in fact listening to York Universe. We are broadcasting live from the LNA Carswell Observatory, located at York University in Toronto, Ontario, Canada. If you head on over to our website, observatory.info.yorku.ca, you can join our OPV online public viewing crew who are trying to look at the moon through the 40-centimeter telescope with the Malin cam, and they are trying to show pictures. And they have a chat window open on YouTube under OPV, and you can go and ask them questions, talk about the moon, talk about what we're talking about here on York Universe. And of course, you can also head on over to Twitter and say hi on Twitter or Instagram or Facebook, York U Observatory. If you are going on to online public viewing from the website, make sure to click on OPV on the menu bar, so that will take you into the OPV session. Tonight, you're listening to Elena and Perandis, and we are discussing the moon, among other many things, and lots of astronomy history. We're about to get started with a little bit of an interview recap for the 200th anniversary of William Herschel. All right, so that is, I believe, all of the the things I needed to remind everyone of. Now, let's go ahead and get started with the reason for the season. This 2022 has been an amazing year for astronomy and also astronomy history. This is the 200th anniversary of the death of William Herschel, who, if you haven't heard before, you'll hear a lot more tonight. He's a profoundly significant figure in the field of astronomy. But he's also one who made his early living as a musician, an oboist, a violinist, a harpsichordist, and probably much more. So last week, the Ellen I. Carswell Observatory, in conjunction with the music department at York and quite a few other people, were all wrangled together by our guest tonight, Dr. Parandis Tajbaksh, and we had an amazing lecture and music concert combination. So, Parandis, I suppose I should let you go ahead and introduce the event just a little bit. For the folks who maybe caught just a recording last time, what was this Herschel event?
Okay, so this was an event that I was planning to actually have in 2020, because 2020 would be the 200th year, basically anniversary of discovery of infrared radiation by William Herschel. But we ended up with the pandemic, and unfortunately everything went into the air. So I was planning this since 2019, and we ended up doing it in 2022. But still, it was nice because 2022 would be the 200th death anniversary of William Herschel. So we still had an occasion to do this, and it would be relevant. And I mean, I first came across Herschel as an astronomer, of course, when I was studying astronomy, and I didn't know that he was also a musician and composer, and a very successful one, until I came across one of his caprices, which are pieces that are written for solo violin to basically showcase the virtuosity of the player, the violinist. And then I realized, oh my gosh, this guy, he was not just a great astronomer, but apparently he was a very good composer too. And then I dug a bit further, and I realized that until he was 43, he was making a living as a professional musician and a composer, and he wrote a huge amount of music. But the thing is that his success and his fame as a composer was overshadowed by his success and achievements in the field of astronomy. So many people know William Herschel as the discoverer of planet Uranus and a lot of other things, including infrared radiation, but they might not know that he was also a gifted composer and musician. So the whole purpose of this event was to bring that aspect of his life into light, and also tell people about a secret passion of William Herschel, and that was, in fact, looking for observational evidence for the existence of life on the surface of the moon. He was quite enthusiastic when it came to extraterrestrials, and many people might not know that. Basically, belief in the existence of extraterrestrials, inhabitants of other planets in the solar system, was quite prominent during the 17th and 18th century when Herschel was living. So it was more like a household belief that, other planets are also populated. What a silly question that you do not believe in the existence of life elsewhere in the solar system. And Herschel was actually the first person who tried to find some sort of observational evidence in favor of an inhabited moon. And of course, He's famous for building these huge telescopes that he went on to make so many profound discoveries using those telescopes. But apparently, the primary reason, the primary motivation for him behind building better and better telescopes was to actually get a better and better view of the surface of the moon to find some sort of, evidence for the so-called lunarians or selenites. So yeah, the Herschel event was supposed to tell people about Herschel as a composer, Herschel as an astronomer, and Herschel as the ET enthusiast. And I am so happy that we eventually managed to join forces and actually have this event and basically introduce Herschel the way that he should be introduced and known by the world, not just as an astronomer, even though a very, basically the premier astronomer of the 18th century, but also as a composer who was definitely ahead of his time and someone who had many ideas about extraterrestrials.
Absolutely, and it's just such a fun event as well. And who doesn't like to think about what else other kinds of life might be out there? I mean, there are those of us who still watch Star Trek regularly. So,
Exactly. So he actually goes on to talk about the fact that moon should be within reach of observations, while he was pretty much sure that Mars is also inhabited. And he was actually the person who discovered the Martian polar caps and the seasonal variation of the polar caps. But I mean, he didn't have hope to see inhabitants on the surface of Mars because he knew that that is pretty far. But for Moon, he had great hopes. And I mean, he actually expresses his frustration that he's still unable to find basically animation, to observe animation on the surface of the moon. But he keeps on going about observing forests and cities and changes of color and things like that on the moon. He really believed that moon is inhabited, and this sort of life could be observed from Earth using a good enough telescope.
Absolutely. And it's interesting now because that same theory is actually one of the debate points about the upcoming Artemis missions, because now we do actually have the technology and there are real plans to put humans on the moon, on the surface of the moon. And one of the debates is, what do you do if somebody wants to set up a moon city on the Earth facing side, because people will be able to see it? Can we, as humans, do we want someone out there that is actually changing the face of the moon for the first time in recorded history? And so it's gone from being looking for that as a sign of life to, well, actually, maybe we shouldn't allow that. Maybe we have them put their cities on the other side.
Exactly. It's interesting that you brought that up, because one of the plans that Herschel has is to actually make a catalog of all the cities that he believes he's seeing on the moon. So what he was really observing were the impact craters on the surface of the moon. But he was saying, okay, so if Lunarians are making these cities and we can catalog them, then we can trace any new structure that they built, because it suddenly pops up in the middle of these cities, and then that would be a proof, a strong piece of evidence for the existence of intelligent Lunarians on the surface of the moon. So he actually proposed to make a catalog of all the structures that he called cities on the surface of the moon.
And that catalog would still be astronomically useful. And I know I have seen on Herschel book recommendations actually a book I've been looking for a while. It's called The Complete Guide to Herschel Objects by Mark Bratton. I don't have a copy myself, but I think it has a full list of all all observations of over 2,400 plus objects, which
Right.
includes his NGC objects and nebulae and all kinds of interesting things. So, might be a recommendation for amateur astronomers now who have
Of course.
medium-sized telescopes to tackle.
Of course, yeah, it would be quite an experience to, look at the objects that Herschel saw and think the way he was thinking. He was populating everything, including the nebulae, the ones that he could basically resolve into stars, the so-called globular clusters. He actually coined the term. And he was basically arguing that these stars are too closely packed together and there won't be enough room in between them for planets. So then he started to hypothesize this hypothesis that maybe the stars themselves are inhabited, because what is the point of God having created all these tightly packed stars, and they're clearly of no use to us, so they should be serving a purpose. It was quite a common line of argument back then, the so-called teleological argument, to come up with a purpose for the existence of something. And he used it very effectively.
Yeah, and without any observational evidence to the contrary, it's an interesting hypothesis.
It is.
With modern small telescopes, you actually can resolve some of these deep space objects yourself. And at the time, of course, William and Carolyn Herschel's telescopes were some of the best. And there's been some arguments made that the 18.7 scope they developed, 18.7 inch scope they developed, is sort of on the same level of importance as Galileo's refractor and the Hubble telescope in terms of what they could then see, just opening up that much more details about the universe, not just the moon, not just planets, not just deep space objects, but globular clusters, and of course double stars was huge, right?
Yeah. He started making a catalog of all the double stars. And we don't use the word double stars anymore. We have the binaries that are gravitationally bound together. But he was the first person that actually showed that Newton's law of gravity is acting outside the solar system by, referring to these binary stars that are gravitationally bound together. So he actually made a huge progress in terms of really making the law of gravity a universal law by showing that it is in action outside the solar system. So his work in making a catalog of the double stars, it was really, really important.
Absolutely. And it is very interesting, the development of gravity. The original equations from the Aryabhata about 1,500 years before Newton was really only for Earth, and Newton then expanded gravity with, of course, his own formulation that was not just Earth, but also the rest of the solar system, providing an explanation for Kepler. And then, of course, Herschel showing that actually it's not just the solar system, but this gravitational force is on other stars too, or around other stars too.
Exactly.
Really
fun. He was aware of that. And the other thing that I think is interesting about Herschel, he was the first person to understand that really when you're looking into space, you are looking back in time. He recognized that idea that because the speed of light is finite, it will take time for light to travel from a star to our eye, if you want to into our telescope, and we are seeing things as they were in the past, not as they are now. So I mean, he was truly a genius. He was completely, of course, self-educated. That's what is intriguing for me, because he never had any schooling, at least in terms of sciences. He went to school, to the so-called garrison school, which was for the families of military personnel. His father was an oboist in the Hanoverian band, and he went to garrison school until he was 14, and then he auditioned and he joined the same band that his father was in. But I mean, he started this journey of self-education, and I mean, he's just a paragon, a self-educated person. And he went on to really change astronomy from, just looking at the solar system or mapping the position of the stars into what we call modern astronomy, the sidereal astronomy. He started applying methods of the so-called natural history, what we call biology today, by collecting and surveying and, making catalogs of stars, and really changed our view of the universe. And of course, he discovered the planet Uranus and a couple of moons.
Yes, of course.
For each
And
of these
we have
guys.
to save that for last week. But I mean, without him, who knows how long it would have been before Uranus actually became a planet. And I mean, of course, he didn't want that name, but
No, he was actually told by people in the Royal Society that he should actually name it after the king. So the solar system would have been like Mercury, Venus, Earth, Mars, Jupiter, Saturn, and then suddenly George. But then
yeah. Well, and I think it's Georgium Sidus sounds a little
right.
better, but
it was George anyway.
Yeah, it's still George. I mean, that name did stick for quite a while. How long was it? 10, 20 years or something?
I think it was for a few years, but the rest of Europe didn't like it, right? The rest of Europe couldn't accept that the name of a Hanoverian king who was ruling England would be left on a planet. And so they actually changed it to Uranus. And of course, then he discovered 2 moons for Uranus. He even believed that he saw rings for Uranus, but that observation is doubtful, and people think that it was more like an illusion that he had, because he was expecting Uranus to have rings just like Saturn. And again, this goes back to this idea that he believed that Uranus was populated by inhabitants, and because Uranus is so far away from the sun, the people of this planet, like people of Saturn, they need more light, they need more objects to illuminate their nights, and they are justifying the rings of Saturn as being an object that illuminates the nights of Saturnian, along with all the moons that it had, because it was so far away. And Uranus was even farther away, right? So he really had doubled the size of the solar system. And he believed that, okay, just like Saturn, Uranus needs rings in order to illuminate the nights of people of Uranus. And he believed that he had seen those rings. But I mean, it is usually, this particular observation is doubtful. But of course, today we know that Uranus has rings. So I mean,
yes, and of course the recent JWST picture really shows those two strong advantage.
Exactly.
But when you see that, remember that is not the telescope that Herschel had.
No.
It would have been much fainter, and it is. There have been people who've looked to see, could it have been just the right angle for the rings or something like that, but it is very unlikely that he actually did see the rings. It says, I agree, it sounds much more like a bit of wishful thinking on that one.
It was, but I guess it was a lucky guess for him. So yeah, we should remember that at least you guessed that Uranus should have rings. So yeah, again, Herschel comes out gloriously here for all of us, along with all the other discoveries that he made in the field of astronomy.
Absolutely. And I'll just say we have to wrap up here, but we'll have to have you back again sometime to talk more about some of his compositions in particular. We will be playing on the recording Wednesday the Caprices 1, 7, 11, 14, and 20 over audio, straight from the event last week. So if you want to catch that, hop in on the Wednesday. And I'll just say a big thank you, Dr. Brandis Tajbak, for coming on tonight. It has been absolutely wonderful, but we
Thank you so much for having me.
Oh, absolutely. And it's been absolutely great. And I wish we had another hour, but we have to wrap up. So everyone, you have been listening to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. I have been your host this evening. I'm Dr. Elena Hyde, and I've had the wonderful guest, Dr. Brandis Tajbak, who was actually the motivator behind the Herschel event, I have to say. Stay tuned because it is Astronomy Night in Canada. Coming up next is Quirks and Quarks, Western Worlds, and Science for the People. You can always connect with us on Twitter with the handle @York Universe, and check out our website for show note content and contact info at observatory.info.yorku.ca. Thanks for tuning in to York Universe. Clear skies and have a good night.
We hope that you've enjoyed this program from AFM Radio, the broadcast service of astronomy.fm. This program has been released under Creative Commons license. Please contact us for details. You may find more of our AFM original programs on our website. It's really easy to find us. We are astronomy.fm. You may also find us in the iTunes radio listings near the top of the News Talk section, and also as an iTunes podcast selection. We'd love to hear your comments. Please email us at radio@astronomy.fm. Thanks so much for being part of the voice of astronomy around the world and across the known